Hello, everyone. Welcome to the South Carolina Linux Users Groups, which is Columbia Linux Users Group. Hi, Ben. In Columbia, how are y'all doing?
I'm the whole group.
And then us here in the upstate Carolina Linux Users Group. Hello, everyone. Good to see you. Glad you could come. And everyone online, glad to see you, Jitsi. Arnold and, well, Jam was here. Where'd he go? Anyway, doesn't matter. Tonight, we got
audio trouble.
Andrew. He's going to be talking to us about the DoD's IT, right?
Yeah.
And well, I
And
guess
me.
I'll, and then you, yes. And then Ben will be talking about Platform One, if is that correct, Ben? Platform
That's
One?
right. Yep.
Okay. So take it away.
All right.
Thanks so much.
Cool. Yes. So I'm going to be talking to you today about a little bit about DoD IT and specifically some of the things it taught me that have proved useful both in IT land as well as even just software development in general. And maybe will be helpful to you as well. And so my name is Andrew Thompson. I work at BMW Group as a kind of cloud architect software engineer. But in a previous life, I was a 11 bang bang grunt. So I got to use all the IT as the end user. And then eventually I switched over to being a signal corps officer, which means you're basically IT for the Army. You know, when I first started it, I thought the signal corps was going to be more like war games, computer stuff like that. But it turns out it's more like just like turning printers on and off for lieutenant colonels that don't know how to use Windows. But that is instructive. And so what I thought today is I would first just talk a bit about the general kind of network that we have for both the DoD, but specifically the Army. So that's kind of the marriage of the radios all the way up to the computers and satellites. And then these are just kind of the lessons that I've pulled out of my time there that I think kind of generalize to generally working in IT. So to kick off here, when we talk about the DoD network, there's probably three terms that you might hear. The DoDIN, which is the DoD Information Network, the DISN, which is the Defense Information Service Network, and then finally the Joint Information Environment. They're all not synonymous, but the DoDIN is the overall network. DISN is sort of the actual IT backbone, so it's the switches, the backhaul, all the physical mediums and not physical mediums that connect. And then Joint Information Network is, again, sort of like DoDIN. It's a term to encompass the whole network and all the systems that connect into it. So there's specific computer services that provide value to different parts of the DoD, and they call that whole thing the JIE. So this is a huge organization. There's so many parts of the network, ways you can slice it, that there's no way we could cover all of it and be comprehensive. And even if we could, it would probably be classified. There's lots of FOIA requests out there for more information about DISN, but the DoD likes to use security through obscurity, and they are not likely to show you all the exact network configuration of how everything's laid out. But I can tell you a little bit, at least, about the slice of the DoDIN that I worked in, which is the Army's network. So DoDIN is all the DoD. We have three main services. The Marines fall in with the Navy. And each of them calls their own special network. They have a different name for it. So the Army calls it Land War Net, the C2 or the C2 Constellation for the Air Force, and then Force Net for the Navy. And if we zoom into the Army Land War Net, the way they split it out, this is the old way of slicing it up. They had upper TI, upper tactical internet, and lower tactical internet. And so this is like for small units, lower tactical internet is all the radios, like things that would go in a Humvee or a truck that the soldiers are kind of using. And then the upper TI is the thing that goes in like the tactical operations center, like in the tents where all the officers and stuff are planning and maneuvering and things like that. And they use something called WIN-T, this Warfighters Information Network Tactical, which is kind of the backhaul methods. So sometimes it's a satellite dish. Sometimes it might be a high-capacity microwave line of sight link. They use a lot of things. But inside of that, there's 3 flavors of network that are encapsulated in that. There's NIPR, which is the non-classified network, SIPR, which is the secret network, and then there's JWICS, which is like top secret. The intel officers talk to other people to find out things on that. And never the 3 shall meet. So these are separated, but because you can encapsulate with VPNs traffic inside a non-trusted network, they can use the same backhaul to provide all 3 kind of networks inside of one transmission. And then ABCS is all the Army Battle Command systems. They've got systems to help them plan maneuver. They've got systems to plan logistics, to plan, fires, field artillery, you name it. They've got laptops loaded with terrible versions of Windows that are getting patched for obscene amounts of money by DoD contractors across every unit in the United States. And so that is the difference between upper TI and lower TI. And this is the old way. They made some changes in the last 5-10 years. And it's really just with the lower TI. They started calling it ITNI. It's basically the same thing, but they're replacing some of these pieces that go in trucks and are carried by people, and they call that lower tier. And then mid-tier, this is mostly in tents or trucks, but they've got a kind of almost like this WinT encapsulated different segments of the network. They've got this wideband network waveform that they can send data for different systems through this at the company or higher echelon level. And just, I guess, as a little explanation, in at least the Army, you have usually the smallest unit would be like a squad, a platoon, a company. Company is about 100, 150 people. Platoon might be 30 folks. And then a squad would be like 5 to 10 people. But so basically 100 and above get this wideband networking. And then pretty much everybody uses this Joint Battle Command platform, formerly known as Blue Force Tracker. This is just sort of like Google Maps for the DoD, really. And it shows you where your friends are, so you don't bump into them in the night. And it can also show you where the enemy is, too. And then finally, we have SATCOM, which allows us to get voice communication or possibly data without having a dedicated link or a terrestrial link, like if it's difficult terrain. And just as a kind of note here, so they renamed NIPR, which is the non-classified network, to SI LAN. I think it's like sensitive information LAN. And then they called it, instead of SIPR, which was catchy, they call it secret LAN now. But basically anything, if soldiers are talking on it, they just consider that secret. And so wherever a radio connects into the computer systems, it generally goes into the secret network, because there could be troop movements. There's a lot of stuff that they just don't want the internet at large to be able to suck back out of their systems, which makes a lot of sense. And so back on the first one, we talked about combat radios. These are things that people carry or go in vehicles. The traditional kind of bread and butter of radio communications in the DoD is the SINGARS radios. And so these are interoperable between aircraft, Navy vessels, and grunts on the ground, Army and Marines. And these are some of the most common ones. Embedders, like a walkie-talkie. This ASIP here can be carried in a backpack, but they also have slots in vehicles, so it's a pretty modular system. You even like stack them up and have a little tiny router that can put a little bit of data through them. And then finally, this ARC is like the plane version of that ASIP that they can put into their helicopters, aircraft. And these are all VHF in the FM range, so 30 to 88 megahertz, which means that it's a line of sight radio, basically. And you're only going to get maybe 5 to 10 miles. Perfect conditions, like if you're on the top of a tower talking to someone else on a tower, you might get further. But usually you're just talking like a few miles. And these generally have 2 ways of communicating. They can either just talk on one frequency, or they can hop left and right. A lot of, even your baby monitor does this now. But back in like the 1980s, when these were initially fielded, this was pretty next-gen, cool guy technology. And frequency hopping actually does a couple things for them. It makes it harder to locate where you're transmitting from, because there's just little bursts of information all across the spectrum. And you have to be able to follow the pattern as they hop from high to low to medium to high to low to, and only if you have a certain crypto key can you follow the hops. So, and then the last thing is it's really hard to jam too, because you can't just jam one frequency. You'd have to jam all the frequencies, because if it's changing 100 times a second, even if you jammed a large swath, you might not actually stop them from talking to each other. So single channel is the old way, but frequency hopping is much more common. Then in addition to those SINGARS radios, we have high frequency HF. So if you are a ham radio operator, a lot of hams do a lot of HF work. It's low. So before we were like 30 to 88 megahertz. This is low, very long wavelengths. And so they can be line of sight. They can also be beyond line of sight, because based on the atmospheric conditions, you can bounce off of the atmosphere and then come back down, sometimes in a different country. So the downside of this is the antennas are a lot more fussy, and it takes a skilled operator to be able to set it all up and actually be able to talk back. But if you're in a remote place where nothing else is working, this can potentially get you talking back to home. And then SINGARS is sort of a sub classification of VHF, but VHF and UHF radios are what we use for just regular talking. And when it's UHF, which is high frequency, so we're talking like the gigahertz range or hundreds of megahertz, that's fast enough based on like Nyquist criteria that you can transmit data. So you can push information from a laptop through it. You can send images. You can connect a lot of systems through a UHF radio. And so we have fielded several that do that. And then finally, we have SATCOM radios. These are, you may notice, some of the same radios, but they're oftentimes dual capable, and SATCOM is in the UHF range. So these are ones that talk straight up to a bird. So these are talking to a UFO, which is a universal. They call the satellites a bird. So it's a UHF follow-on satellite. And so there's not unlimited numbers of these. So they have different ways, depending on what kind of mission you're on. You'd request either a dedicated slice of the bandwidth. So like, think of like a radio station, like maybe you just get this one single channel, or they have, much like your cell phone, have a TDMA, they call it DAMA, but it's like a time sharing where little bits of voice or data get sliced in along with everyone else's data on it. And there's a new version of that, but that's basically what these do. So with all these systems here, the first thing that running this taught me is that in the end, you're always going to have trade-offs, and there's no perfect system. And so I don't know if you've heard in distributed system land, there's this thing called the CAP theorem, where if you're trying to make a distributed system reliable, you can only pick two of these things: consistency, availability, or partitioning. And so you might be able to get two, might be able to only get one, but you can never get all three. And I feel like in the world of IT, this is like our CAP theorem of complexity, which means user training. As it gets more complex, fewer people can actually use it effectively. But that's kind of juxtaposed against security and usefulness. So if it's just a potato, anybody can use it, but it doesn't do that many things. And then the last thing is cost. And so if it does everything, or say you like buy multiple versions of it so you can segregate networks, it gets really expensive. And this isn't just the DoD. Pretty much everybody has this problem of user training, whether it's security or just how to use a new program. And the more user-friendly you make it, the easier it is for someone to punch holes in your security. And so I still find myself fighting these trade-offs in IT land. So, oops, actually, one sec here. There we go. Okay, and then segmentation and encryption. So here in our land war net we talked about here, we have the NIPR, SIPR, and JWICs are all air-gapped networks. So I'm not saying it's never happened, but those two should never cross. And if you have stuff that you really don't want to get out, you just can't trust a user not to click on an email link or plug something in. And so segmentation is a very effective way to ensure your either security or dedicated bandwidth if you don't want one service to hog all the CPU or something. And I think while the Army does this mostly for operational security, this is something that you can use if you're doing, Azure AWS infrastructure. Like if you have a very sensitive part of your application that does PII or something that just you're very worried about, you can have a separate VPC and compute and not add any networking between those things, or only have a very small, very locked down channel. And so I still think that's something that applies to the IT land of segmentation, and just not, firewall is a loose barrier, but actually physically separating them so there's no network interfaces is still a valid thing to do. And then on encryption, there's kind of, I think of like different layers of how much, kind of security you can have in depth. And so the easiest to implement is symmetric key encryption. So this is what the Army often does because they know who they're talking to on the other side. So they can have a pre-shared key ahead of time. They distribute all the keys, everyone has it, and then they can talk. And this is good because it's faster, it's more efficient. And so if you know everyone that you're ever going to talk to, symmetric key is just fine. PKI, so this is public key infrastructure, so you have a public and a private key. This is something that is more important on, like, say, the web, where I don't know who's going to be visiting my website. And so PKI is something that like the DoD uses, but oftentimes they fall back to symmetric because it's cheaper and faster. And then the final is like zero trust, where you kind of open everything up, but nobody trusts anything, and you have a lot of different PKI and other methods of authenticating who you're talking to is who you think it is. To my knowledge, I have not been in the DoD in many years. They're trying to use a combination of all three, but air gapping through segmentation and symmetric key encryption in between nodes is probably their bread and butter, because it's been around for a really long time, and as long as you have sufficient key lengths, that usually does the job. So another lesson was when to do compute on the edge versus when to have it on one big server like a mainframe. And I would say the Army, especially, and really any other service, has tended to go towards the edge, because you just don't know when a mortar round is going to fall on HQ, and they don't want that to cut off all services for all the subordinate units. And so even at the battalion or squadron level, which we're talking about 1,000 soldiers, we would have full network stacks, even like compute, like blades that could run virtual services, a lot of laptops, and backhaul separate from going through our next higher echelon, because they care about redundancy. And I think this, the lo-fi local first movement has kind of been pushing this direction recently, where people like to not just rely on some SaaS platform where they have to have internet to connect to their services. If you can run it locally in a container on your home network, this makes sense for a lot of people. And even in like business applications, not having too many dependencies that need to be linked by the internet makes a lot of sense. However, centralization can also make sense because for certain things that are, say, really sensitive, you might not want that sensitive data at every edge location where it could potentially be compromised. And you can get efficiency from all the compute being in one place and having one big box, rather than have to pay for 10 separate boxes that won't run quite as fast. So that's definitely a trade-off that I think everyone makes. And there's a picture of a I think that's probably a battalion level stack where they're all in these green boxes, and they take off the ends, hook all the cables up, and start talking. That is, that's an example of one of the racks they use for networking. I think that. Oh yeah, and so basically, so how much do you care if the network drops out? Do you still need that service? In that case, whether it's your satellite business office locations or something else, I think you still need to think about this in IT land. And then we talked about the costs versus efficiency. And then finally, latency. If you're doing it at the edge, it's faster, whether you're serving websites or just doing compute. And so it can make sense in a lot of applications to do closer to the edge computation rather than having it all go back to a central server API. Okay, so pace and other tricks to keep the network up. So PACE is an acronym that the Army uses, which is Primary, Alternate, Contingency, Emergency. And anytime you're planning an operation with communications, they don't just want to say, oh, we'll use this one radio system, and that's going to be it for the whole operation. They always have an alternate. They generally make you do a contingency. Sometimes the emergency is kind of a joke. So it might be something like, digital messaging through their, Blue Force tracker. Alternate is voice communications over frequency hop net. Contingency is falling back to single channel, and then emergency is SATCOM because it takes longer to set up and you need a more skilled operator to actually point at the bird. But this little diagram here of like a modern day kind of tactical network, you do see that there's several different ways. This is like a terrestrial microwave. There's satellite communications, and there's usually voice communications here. So they'll have all these working in unison, but there'll be a primary where they try to push most information and they only fall back as they go through. I think this matters in regular contexts where if you only have a single internet provider and you don't have, say, like a 5G back, something to fall back on, depending on what kind of business you're in, it would be really unfortunate to have your entire business go out because Spectrum's having a bad day. So I think for any business over, like a few hundred employees, you probably need a little, maybe not a full PACE, but you should at least have a PA, maybe a PAC, that can give you degraded, communications in the event of emergency. And along with this, just looking at your network topology and figuring out where the single points of failure are is a worthwhile thing that Army communications planners do. And what they'll do then is either they might double it up, so they might have 2 links instead of just one, where they're stretched thin. Or if it's like an equipment thing, having spares matters. And I think this is 100% of a thing in IT, where if you have like a single, they call it a little fiber nicks that go into, like if you only have one of those and it burns out, like you're cooked. So figure out where the single points of failure, to include your personnel single points of failure, where if Jace is the only smart guy that knows how to reboot the something server and he doesn't come into work today and it crashes, like we're all done. So finding those single points of failure and having a plan of, oh, now Olivia is the alternate, is very relevant to things we do every day. And then I think last is, in the Army, we do something called retrans, so retransmission. So if you're going over, say, like a big mountain, you'll put a truck on the top of the mountain that is just taking in, radio communications on one side and re-beaming it out on the other side, sometimes digital. And oftentimes you don't need it for distance in regular IT, but you certainly need to look at where you might need to change media, like go from a fiber connection to a high capacity microwave link to bridge over that last mile between like office buildings. And that can also really improve your redundancy or your reliability of your network as well, having multiple mediums bridging through so it's a network and not just a Christmas light string. And the final lesson that I learned was the power of documentation, standards, and how the crushing weight of bureaucracy of too much of a good thing can really ruin the whole picnic. And so on the positive side of this, the Army Publishing Directorate, I can see if I can just click on this here, to show you this website. So this, you can just Google it, Army APD. The Army does an amazing job of just writing documentation. They have a kind of a tiered echelon of at the top are these ADPs, where these are short, like you and your grandpa can read through it in 5 minutes. Like if you just want to know, why do we have an Army? This PDF in pretty plain English will tell you exactly why they say we do this, and they'll describe the main functions. They have like functional things that they need to go through. But I think this is all of like 30 pages or something, and they have like helpful pictures. And then within these things that they describe, they'll have so they talk about like fires, intelligence, operations, stability. And so they've got ADP, and then within the publications, they have more detailed ones called ADRP that talks about the kind of reference of exactly how you do it. And when you break it down to tiny little steps that you can give a soldier, and like, here's 10 steps to, replace the water filter on this water tank, you get down to like ATTPs, and it all nests in really nicely. And so, like, you never have to wonder why you are doing this, because you can find the documentation that shows you exactly, we don't have clean water, then the people get sick, and then they get sick. And this is just like, it's helpful because it's such a large organization. And I guess the trade-off that I want to talk about here specifically is that when you have a lot of documentation, there is a cost to maintain that. And if it's just 100 documents, that means every time you make a small change to your network topology, someone has to go update that diagram. And similarly, if you decide, it's not that great if you turn this 3 clicks right, it should really be 4 clicks right, then you got to like update this book. And in places where there's a lot of high turnover in personnel, this might make sense. Or it's just like the same person might not be doing it. Like if you have a really iffy CI/CD procedure where it's not actually all automated, and somebody has to know exactly, like, edit this YAML on line 13, make sure it doesn't say this. You might want to write that down so that, if it's not you next time, the next person has some steps. But this is, to me, a trade-off where you just got to decide for your own organization, how big are we? How often is this get used? So should we write it down or not? And when you do that, it makes you not have to think about as many things in your head. So people can move faster if it's just a checklist of things to go through. And you don't necessarily have to hire a like CI/CD ninja that has been doing this for 20 years. You might be able to take a junior and get them up to speed if you've done an okay job of documentation. However, taken to extreme, both the standards we describe exactly how everything needs to be and the ways to do it creates a very non-agile, unnimble organization, and it can just suck you into the slowest, most unpleasant place to work in the world. And that's part of why I'm now working for BMW Group and not for the government, because they love documentation and standards. Like I said, it's glorious when it all works. But if there's too many processes, too many forms to get this done, it can just really slow down the efficiency of your organization and not actually help it anymore. And to illustrate this fact, I have a fun case study of something called JTRS, the Joint Tactical Radio System. So this is a fascinating debacle, and it's almost like the Joint Strike Fighter program, the F-35, which just ran billions over budget, and they would crash and stuff like that. It took us a long time to get those new fighter aircraft. This is like the nerd version of that, where they had this plan where, before we talked about our SINGARS radios and some SATCOM radios and everything in between, they were going to make one radio, is like the ring, to rule them all, that could talk on all these different waveforms. And it would be a software-defined radio, which in a way is a concept that's been around for a while. Like your phone is more or less like the baseband processor is like a software-defined radio where it can talk different languages, so to speak, to different things. But the DoD, as is wont to do, really waterfalled and spec'd the life out of this. And the original plan was to have 3 kind of subsections. So there was handheld, man-pack, and small form-fit radios. So these are things that would be carried. There was the ground mobile radio that would go into like tents and vehicles. And finally, there was the airborne, maritime, and fixed stations. This is going into buildings, aircraft, and boats. And what basically happened with all this is it ended up costing about $10 billion before it was finally canceled. And very little of this ever saw production. So our good friends Boeing, they were too busy designing the like exit doors on aircraft. And so they crapped the bed on the whole GMR thing. We never saw any of that. That's gone. I believe a decent amount of the AMF got either scrapped, or it got split into 2 smaller SALT and SANR programs that I think still haven't actually produced anything that's like been fielded, but we might see it in the next couple of years. And then throughout all this, there's 2 big communications equipment companies, Thales and Harris. Like I think Thales has an office here in Greenville. and they're based out of some Norwegian country, I believe, like Nordic. But they have this kind of walkie-talkie called a 152, PRC 152, that they'd already been selling, and they decided not to go all in on jitters. But they like looked at the spec and were like, we're not going to do all this, but we're going to do most of it. So on the side, not officially in the program, they made jitters compliant radios that met most of the stuff. And so there are some radios that could kind of do everything they wanted. And so they took 2 of those radios and stuck them into like an airborne radio that now pretty much works with what they wanted. And then what's crazy is we actually got 2 things that were built on the HMS side. So the first one is called the PRC 154, also known as the Rifleman radio. The whole exciting thing about this is a mesh network. It's like mesh-tastic, where you might not, your radio by itself might not be able to reach that far, but if you could hop across 5 different soldiers, you'd be gravy. But so there's a software radio, but it wasn't backwards compatible at all with any of the old SINGAR stuff. It used weaker encryption than the embitters or the ASIPs. So that was like reasonably insecure. It only weighed about 1.5 pounds and had a GPS receiver built into it. It's kind of cool. So it could, like, as you keyed the radio, it could show where you were. But the range on this thing was atrocious. I think I used this at one point, and it just not a good radio. And then the PRC 155 man pack was twice as heavy as the ASIP, the SINGAR's version of it. So twice as heavy, at half the range, 20% of its battery life. And yeah, there's just, and this all could have been prevented had they just had been more effectively run. But they made the software-defined architecture really complex and very Java-y, like all these like abstractions and like inheritance classes. They called this Corba, which I think was Common Object Request Broker Architecture. They called this whole thing like SCA, and to be able to like hit all the specs to be able to like field a radio was just a monumental task that only like the Raytheon and Boeing's in theory might have been up to, but a combination of them and the program oversight, this never really worked out. And that's your tax dollars. So taken to an extreme, too much standards and documentation is not a good thing. And yeah, that's I don't have an end slide, but those are the things that I learned working in the DoD. And hopefully you can apply a couple of those lessons yourself. I was in the service from 2009 to 2016, maybe 17? 16. Yeah, so not quite out for a decade yet, but I'm getting there. So if any of this is out of date, send me angry tweets and I'll fix my slides. But yeah, does anybody have any questions, I guess? Happy to answer what I can. All right. Well then, I guess, Ben, did you have something for us?
Anyone online have questions?
No, I'm good.
Okay.
But thank you so much, Andrew. That's was excellent info, and I got a couple war stories for you. I was in the service a little bit before you, and let me go ahead and share my screen. Entire screen. Yeah. Okay, that'll work. Okay, so some more stories about being in the field in the Army. Two that I vividly remember. One was you were talking about that PRC 154. Well, before your time, there was a PRC 112. I believe it was a 112, but it was just like the one you showed, that little radio. And normally that thing could only talk for a couple miles at best. But that was designed for just scouts that were out and trying to, relay information back to the lines. Well, I ran into a scout platoon leader that was so good at. He must have been best friends with a signal officer like you were, Andrew, and he knew all about antennas, especially long wire antennas. And back at that time, they had a long wire reel antenna that was 100 meters long, and it was rolled up on a little spool. And so you could take this long wire antenna, hook it to your PRC 77 or PRC 112, and walk it across a field and hang it on a tree, and that thing would propagate a long way. For example, while we were on a field exercise with this scout platoon leader, he was talking on a prick 112, 17 kilometers with that long wire antenna. And later on, he was so far out, they were like 35 kilometers out, talking back on a regular VRC 47 radio, which is just a vehicle mounted radio. He was talking 35 kilometers back to headquarters. So I was just really impressed with how Army gear performed with a smart platoon leader that knew something about field communications. The second war story is about the doggone pine trees that were in Germany at the time. I remember one time we were sitting on top of a hill, should have been talking to the whole world with our vehicle mounted VRC 47s, and we couldn't talk to anybody. And I was going crazy. The NCO I was working with was going crazy, and ended up into a big fight. And turned out all we had to do was move the vehicle to a place that didn't have any pine needles, because the pine needles were taking all the VHF traffic that we were sending and just scattering it to the winds. So that's my war stories about Army communications. But anyway, I hear that about Army development being difficult, and there's so much money in the DoD. I mean, 20 years ago, somebody did a study of how many DoD siloed systems there were out in the world, and because the consultants stopped counting it at 10,000 systems, and that was 20 years ago. So I don't think it's gotten much better since then. And the whole idea of DoD software development has always been waterfall, which we all know is slow, and then by the time you get to a finished product, the requirements have changed, and the customer doesn't even want what you built anymore. So that should be going to Agile, and with 100,000 developers in the DoD, you would think sometime we're gonna figure this out. For example, if we go right now that's not it. Hold on. I just meant to go and search for puckboard. I don't want puckboard.com. I just want to search. There we go. Okay. All right, here we go. Puckboard@dso.mil. This is a whole application that the Air Force uses to run the scheduling for the entire Air Mobility Command.
That P is kind of unfortunate.
I'm sorry?
The P is unfortunate. The way they rendered it.
Yeah. Anyway, a good story about this. Let's see. Oh, I want to do World War II. Flight briefings. Sorry, this is a little tangent, but here we go. Here it is, right here. See this? This is how they used to track flights in World War II. There would be a chalkboard, and there would be a flight number right here, and then let's see, there would be his takeoff time, his altitude, the ordnance he was carrying, and the target. All kinds of secret stuff that you're don't want to let the enemy know. We were still doing this up until 2019. And it wasn't a chalkboard anymore. It was a whiteboard, and it wasn't chalk. It was dry erase markers. But that's the only thing that changed. And then some smart captains and majors had heard about a program called Platform One in the DoD that had just sprung up in 2018, led by a guy named Nicholas Shalon. Let's see, this guy. Ta-da! And he came to the DoD in the Air Force, and he said, "Listen, I am an IT guy. I care about how the U.S. does defense, and I want to change the whole way we do business." So he started Platform One. This is Platform One, and it is a way to run, a way to get rid of the waterfall. You see, and they chose a Star Wars motif and said, "Okay, well, we're gonna attack the waterfall and say waterfall only you can prevent." So that's their little Yoda, unofficially their little mascot. And so he created all this. And the Air Force guys said, "Oh, this is so cool. This is a way to run workloads reliably, sustainably. And if your process dies, we just spin up another one, and you don't have to worry about it." And that is run in one of the value streams of Platform One called Party Bus right here. And there's an onboarding process. And there's a whole service catalog of stuff you can choose, and there's a whole bunch of resources that you can use. So what Party Bus does is you get your application, you send it to the Iron Bank right here. It gets containerized and put into the Iron Bank, so that your application has all the libraries that it needs to run. The saying is, if it runs on your laptop, it'll run on the server, and that's true. So Iron Bank's job is to scan your application, make sure it's good, and then make sure it's secure. And so your application is, they scan it, take a hash of it, make sure it hasn't been changed, and then it gets submitted to a pipeline, and your pipeline runs, and you get your output. Or website or whatever. CNAP is the cloud native access point that allows secure access to the environment. Big Bang is the Kubernetes software underneath Platform One. And then, of course, everything has got to be secure. So they have a whole team doing cybersecurity. So anyway, going back to the puckboard guys, a couple of smart captains says, this is stupid that we're doing this World War II stuff. Let's do scheduling right. And so they created a puckboard using the Party Bus from Platform One, and completely changed the Air Mobility Command, which was at the time was doing 1,000 flights a day insecurely. Pilots were actually taking pictures of the whiteboards that their flights were on. This is, very secure, unsecure information, and they were sending it to each other over Facebook Messenger. And so that wasn't a good situation. And so Puckboard allowed them to schedule their flight securely and only give access to the people that need it. And that's what Platform One enables. So, and really smart group of people. I think they started out with, they got a link to them here. One of the main applications that they had to get going first was Mattermost, which was like a clone of Slack, but it's an open source version of Slack. And so they stood that up and said, okay, instead of communicating with Facebook Messenger, we're going to do Mattermost, and that's going to be our first big success, and it was. Okay. So if you're interested in doing the new best way of doing software in the DoD, this is the team right here. I was on it for a year, and they were just an outstanding group of people. All right. So fun fact, I'm not telling you anything that isn't out there in is unclassified. So here is Repo 1, and this is a publicly available repository for the Big Bang code that runs Party Bus and everything else on Platform 1. This is a GitLab repository, and here is the Big Bang product. And here's the docs, and here's the code. The renovate process checks for updates to any packages that you have. Big Bang supports 37 packages right now. All kinds of packages, and they're all open source, well, except for Jira and Confluence, but everything else is open source and ready to go. So if you, as part of, whatever company that you're working for right now, want to take advantage of this, you can. It is on GitHub. This is GitLab that you're seeing here, but a version of this, well, an exact clone of this Big Bang software is copied over to GitHub every night. So you can go to GitHub and see the same software. And search. Oh, come on. I don't want to sign in. Well, all right. It's on there. If I just search for it this way. There we go. DoD Platform 1, Big Bang. Ta-da! And Big Bang is just a collection of Kubernetes scripts that allow you to run all of the packages, all the 37 packages that are in Big Bang proper, and it's good stuff. Now, as far as Nicholas Shalon, he did this for 3 years until September 2021, and he got the team going and doing all kinds of great stuff. And then finally came to he had a fight with the brass and got tired of cutting through the DoD red tape, I know you can empathize with that there, Andrew. And so he quit. But it didn't take his team with him. Everybody that started the team was, kept on plugging along, and he's got a company called Sage now. He's one of these entrepreneurial serial entrepreneurs that just keeps going from inventing new companies and doing new stuff. What is that? Okay. And he likes to bring attention to this Chinese Communist Party is using TikTok to manipulate election results and all this other stuff. But you can learn with Nick Shalon using this course, and he's got an article about using the strangle pattern to move your monolithic legacy app to microservices. So, I talked about value streams that are part of Platform One. Party Bus will run if you're a big DevSecOps dude and you got a big team, you got a 10-person team that can handle this, then you can actually download the code from GitHub and run it yourself. If you don't want to do that, if you're just 1 or 2 person shop, then Party Bus is for you. Especially if you're in the Party Bus is only for DoD personnel. But if you're in DoD and you want to run your workload, doesn't matter if you're Navy or Army or Coast Guard or Marine Corps, you can run your stuff on the Party Bus as long as your application can be put into a container. They will take it and they will run it and make sure it's up and running and good to go and secure. They'll do all the cybersecurity stuff, and they have an onboarding process to get you going. And it'll take a couple months to get your stuff working, but that's a lot faster than a lot of things happen in the DoD. All right. That's about all I wanted to say on that. Anybody have questions?
Ben, is this just on Nipper, or do they use this to host things on like Sipper and like the secret network as well?
This is aisle 2. When I say aisle, I mean information level 2, information level 4, and information level 5.
Sensitive stuff and not as sensitive stuff.
Right. Yep. Most of the business of the DoD is that it's just business, ordering parts and supplies and personnel rosters, and some of it's PPI, personally identifiable information. So you got to take proper precautions for that.
So you won't find out who killed Kennedy on anything hosted there, but you might be able to find my social security number in my time.
Well, that's unclassified. I'll tell you after a couple of beers. But yeah, that's so this is the new DoD, the one that's doing everything in the spirit of 1969 when they invented the internet, and we're thinking about reliability and what happens in the case of a nuclear attack and all that. These are the guys doing it. So if you want to work for a great bunch of people, find one of these teams right here. They're all, the total platform team is over 100 people, so yeah, it's a good sized team. Any other questions?
Olivia, did you say your company works with them? Oh, Cloud One.
Oh yeah, but yeah, Olivia, I responded to that email I don't know how it is now, but the Cloud One, Platform One relationship was a little bit strained because the way Big Bang operates is they were relying on Cloud One for a while, and now I'm not sure they are. So I think that's all I can say on that.
Huh. So it looks like Cloud One is sort of like a competitor to Platform One.
No, I mean Cloud One is supposed to be infrastructure.
AWS.
Providing, it's supposed to be the military version of AWS. But the military can just go and buy AWS directly.
Platform One is more like the Azure App Service or Elastic Beanstalk or something.
Yeah,
You
exactly.
can containerize it; they'll run it for you.
Yep, that's it. Yeah, and so Party Bus is the way to go for a small team. But if you got the people, then you can do Big Bang all on your own.
One is still like part of the Air Force, right?
It started out in the Air Force, but I don't know how he did it, but he got somebody in the DoD to say, "Hey, we're doing this, the biggest and the baddest of anybody out here. So just make us the DoD standard." And so when you go to Platform One, they're talking about there's no Air Force here. This is all DoD stuff. So they branded themselves as the standard for DoD. But if you talk to the Army Chief Information Officer, he'll deny that. If you talk to the Navy one, he'll deny that. So it's kind of a branding game and trying to capture the best, the most amount of bucks with the sleekest, fastest platform, most reliable.
That makes sense.
Yeah. So, but yep, that's all unclassified. And let's see if the if you search for Nicholas Shadlan and then ask for why he left. You'll get all kinds of links from Federal News Network. This was all public, and he didn't have an NDA, so he said, "Hey, you can't just be given information technology systems to some major that hasn't been doing it his entire life." And so he got mad and left. That's not what they did with Platform One. The major I know that was running all the tech stuff for that was he was cut from our cloth. Let me tell you, he was he had his own home lab in his house, a whole server stack, and doing all the things that we would do at a normal, Southeast Linux Fest or wherever conference that we go to. So he was great. But selling this to the rest of the DoD is kind of it's hard because some parts of the DoD just like Microsoft products, and you come in with a Linux-based system, and they're like, "What? We don't know how to do this." and Platform One guys are like, "Yeah, we know. We just containerize your app and give it to us, and we'll run it, and you'll be good." All right.
Well, thank you, man. Appreciate that.
Yep, no problem.
Thank you, Andrew, for both of you for tonight's talk. Very informative. Very interesting. I guess we'll adjourn. Y'all have a good evening.
Yep. Okay. See you, Jace.
See you, Ben. Thanks so much.
All right.
And I never heard the live streaming show. Yeah.
I don't think so, because I lost a meeting. I guess we'll find out.
You want to message him? Yeah, I guess I don't know. Do something.
If he starts it, if he signs back in and starts it up again, it will just overwrite whatever. That's what happened. Previously.
Wait, Angela, do you know about the fence parts?